Now I'm going to show you how to analyze the children TV hours. If you want the analysis to be in the same project as the previous analysis, you need to go up to Create a new table and graph. We want column again, and for the children TV hours, we have the sample size, the sample mean, and the sample standard deviation for each group, but that's all we've got. So we need to enter and plot error values already calculated elsewhere, and from the drop-down menu, we need to select what information we've got. And in this case, it is indeed the mean, standard deviation, and sample size. So then we say Create. Again, I'm going to give the data a title. TV hours will do. Now, this title for the first group is clinically obese, and for the second group is not clinically obese. The clinically obese mean is 5.52 with a standard deviation of 10.44 and a sample size of 103. The not clinically obese, the mean is 4.74, the standard deviation is 6.57, and the sample size is 95. Having done that, we click Analyze. We want to do a t-test comparing clinically obese and not clinically obese groups. So we say OK. We need to choose what type of test to do. At the moment, I will assume that both populations have the same standard deviation. It's unpaired because children cannot be clinically obese and not clinically obese at the same time. In the options, the exposure is clinically obese, so I want that to be first minus the not clinically obese. And I want the descriptive statistics again. So I say OK. First, I'm going to check the F-test to compare variances. This time, significantly different is yes. The p-value is very low. This means that the null hypothesis of the standard deviations being equal is not true. So we need to assume unequal standard deviations. So I actually need to do the analysis again. So I'll go back to the TV hours dataset, click on Analyze again, and I want to change the parameter of the existing analysis, modifying the results. I go back to experimental design and I correct the error I made and say OK. Notice how now it says unpaired t-test with Welch's correction. Welch's correction is what is done when the standard deviations are unequal. Now we can look at the results. We've got a p-value, we've got a t statistic and degrees of freedom, we've got the mean number of hours of clinically obese TV, not clinically obese, we've got the difference between means, we've got a confidence interval, and the confidence interval includes 0. So in this case, we'd be saying that there's no difference between clinically obese and not clinically obese children's TV viewing hours. As before, after we've done the analysis, we need to do the hypothesis test steps, and in the writing of the steps, write down what we've found from the analysis.